Welcome, guys. Today we'll be solving another question from your text. We'll be solving question 19 under exercise 1A, chapter 1 of the New General Mathematics for Senior Secondary Schools, book 1. And the question simply says 5x squared times 4x raised to the power 0 times 2x raised to the power minus 6. So clearly, this is a problem under indices. It's a problem under indices, and like we always tell our students, before you get started, before you go through what we are giving to you, solve this on your own first. Then you compare it with the solution we'll provide for you. You see, so let's go straight into the solution. In solving this problem, we're first going to expand these terms. 5x squared times 4x raised to the power 0 times 2x raised to the power minus 6. 5x squared is the same thing as 5 times x squared. Now, why is it not 5 squared times x squared? Reason is this: the 5x is not in parentheses. 5 is a different term from x. They are not both affected by this exponent, which is 2. So what we have is the solution that x is affected by the exponent and 5 is not, because 5 and x are not in parentheses together. So it's 5 times x squared. This is 4 times x raised to the power 0. This is 2 times x raised to the power minus 6. And I hope that is quite clear. From the laws of indices, we've said it before several times. X raised to the power minus a is equals to 1 divided by x raised to the power a. So anything raised to a negative exponent is 1 divided by that term raised to that positive exponent. So x raised to the power minus a is 1 divided by x raised to the power a. So if we apply that to our question, x raised to the power minus 6 here will become 1 over x raised to the power 6. So the equation will now become, okay, let's look at the x raised to the power 0. Now, the third law of indices says anything raised to the power 0, so far that variable itself is not 0, it's 1. So x raised to the power 0 is 1. 1 raised to the power 0 is 1. 2 raised to the power 0 is 1, 3 raised to the power, anything raised to the power 0 is 1, and that's the third law of indices. So if we apply this to our equation, we're going to have a situation where we have 5 times x squared times 4 times x raised to the power 0 times 2 times x raised to the power minus 6 being equals to 5 times x squared times 4 times 1. The x raised to the power 0 becomes 1. Times 2 times 1 over x raised to the power 6. X raised to the power minus 6 becomes 1 over x raised to the power 6. So from this, it becomes easy to gather whole numbers and gather the variables. So let's see there. 5 times 4 is 20, times 2 is 40, times 1, 40. So we have 40 times x squared times 1 over x over 6. So it's 40 times x squared over x raised to the power 6. And definitely, you know that anything from the second law of indices, x raised to the power a divided by x raised to the power b is the same thing as x raised to the power a minus b. So x raised to the power 2 divided by x raised to the power 6 is the same thing as x raised to the power 2 minus 6, which will give us x raised to the power minus 4. We'll show more of that in a bit. So let's go. Let's do this. Yeah, so what we have is 40 times x raised to the power 2 minus 6, and that gives us 40 times x raised to the power minus 4. which is 40 divided by x raised to the power 4. If you remember the fourth law of indices, which will be also treated in this particular question, we say x raised to the power minus a is equal to 1 over x raised to the power a. So this x raised to the power minus 4 becomes 1 over x raised to the power 4. So it will be 40 divided by x raised to the power 4, and that is your answer. So before we go, we'd like to remind you to hit the subscribe button. Let us know if you want us to continue with this series. The more people hit the subscribe button, the more we provide these solutions for you, because then we know more people want this series. And that will help us to get to the SSE past question and the UTME past questions, and we'll solve everything for you. I can get them online. So hit the subscribe button. The more people hit it, the more we solve these questions, the more we know you really want it. So thank you very much. Have a great